Hello everybody! In this video we're going to be answering another probability question. So again, we're going to be getting a probability estimate for the following question. Let's say I have a length 5 vector of random integers between 1 and 3. So remember, the way I can do that is I can say rand I. So between 1 and 3 I put 3, and then if I want it to be length 5, I can say give me 1 row, 5 columns. And my question is, well, what's the probability that these numbers appear in increasing order? So let's see here, 2, that's fine, 3, that's fine, but then it decreases to 1. So this is an example of where it's not in increasing order. Let's try it again. This one definitely is not, because we have 2 and then 1, 1, 1, 1. Let's try it again. 3, 2, nope. 3, 2, 1, 3, 2, nope. So I could sit here and kind of run this a whole bunch of times by hand until I find one, but MATLAB can do it much faster than I can in a for loop, so let's do it that way. So let's set up the computation. What I'm going to do is I'm going to create a new function, and I'm going to just minimize the command window a bit. Let's call the function, let's call it check probability, or check prob. Again, like usual, we're going to have n represent the number of experiments, the number of trials, and as output we want to give a probability p. Again, I'm going to leave space for our helper variable in just a moment, but let's start by saying for I equal to 1 to n. So this is how we're going to repeat the experiment multiple times. Then we create our vector v equal to rand I of 3, comma, vector 1, comma 5. So exactly like we were doing in the command window, this is giving us the random integers between 1 and 3, and we're picking 5 of them and putting them into a row vector. Then what we're going to do is we're going to say v, and we're going to ask, is this equal to sort v? And this is not quite going to give us what we want. Let's remember how this double equals works. So let's come here and say, again, I'm going to set v equal to this rand I3, comma, quantity 1, comma 5. So here I get 1, 2, 3, 3, 2, 0. And what this does is if I do, let's say v of sort, what this does is sort the vector for me. Oops, I did it completely backwards. Sort of v. So here it has 1, 2, 2, 3, 3. Now if I do v double equal to sort of v, remember this is going to give me a length 5 vector where it returns 0 if the first position of v is equal to the first position of sort v. I had that completely backwards. It returns 0 if there's no match, 1 if there is a match. So let's see what this does. So this is saying the first element of v is equal to the first element of sort v. The second element of v is equal to the second element of sort v, but not the third element, not the fifth element. So again, here's sort v, and we can see here in the workspace, let's take a look. V goes 1, 2, 3, 3, 3, and then 2. So that's how sort works. So we get this logical array of 1s and 0s. So instead of having this v equal to sort v, we should use the keyword around it. So remember, all. And what am I missing here? So we're saying if every element of v is equal to sort v, so I need if. Then what I want to do is increase our success count. So let's say we start with 0 successes, and then we say s is equal to s plus 1 if we found a case where v is equal to the sorted version of itself. Let's end the statement. If statement, let's end the for loop. And let us not forget to define the probability. So we're going to say p is equal to the number of successes divided by the total number of trials. So let's save it and do some experiments with it. So let me just clear the screen for us. So now let's say check probability. Let's do 10 experiments. So here we see 0%. So we can run it again, and here we can say 30% chance. So again, with small number of trials, we get a big variation in the results that show up. But now let's try it with something like 10 to the 3. And we can see here, all right, about 9%, we can round up to 10%. Let's try it with 10 to the 6. And let's see here, we get about 8.6%. So hovering looks like a little bit under 10%. We can run it again with a million experiments. And here 8686. So this is looking okay. So we can say about 8.6%. So I think this is a good place to end the video. Thank you for watching, and I will see you in the next one.